So again, Algebra 2 is all about taking real-world situations and turning them into functions. So we are doing more and more modeling of these polynomial functions. Except right now, they're giving you the information, and then you just have to analyze it. So below, we have this Dizzy Lizzy amusement park, and the park is studying the wait time at their most popular roller coaster. And the table below shows the number of people standing in line for the roller coaster T hours after Dizzy Lizzy opens. So before I even start looking at anything, I want to really understand this graph right here. This is how many hours have gone by, and this is how many people are in line. All right, so T is hours, and I look down here in my graph, and indeed it's the X variable because it's listed first in my table. And then P is the amount of people in line. So Jalen made this lovely scatter plot and decided that a cubic function should be used to model the data. His scatter plot and curve are shown. Now it makes sense that it's cubic, so we want you to understand that already, that it has a tail down and a tail up, and it crosses at 1, 2, 3 spots the x-axis, so therefore it has to be cubic. All right, so what kind of questions would they want us to understand and glean from this graph? They want you to be able to look at this graph and see at which time the wait line is the longest. Now, if you notice here, this graph goes on forever and ever. So it's impossible for this graph to go on forever and ever because the park has to close at some point. And it looks up here that the park is open for 12 hours. That's when it goes from having no people in line right when it opens to right about here looks to be about 12 hours. So all this other part of the graph is stuff we will ignore because we're basing this on a real world situation, right? We can't have negative hours and negative people waiting in line. And we certainly can't look just at the 72nd hour or something way out here because the park's just not open. There's only 24 hours in a day. So where's the wait time the longest? The wait time is longest obviously here at the relative maxima. And it looks to be, well, if I count over, that looks to be 1, 2, 3, 4, well, there's 5. It looks to be about 5.5 hours into the park opening is when the line looks to be the longest. So at that 5.5 hours, if I were to come to that park 5.5 hours after it opened, how many people would be waiting in line for this roller coaster? Well, I look at the Y value, and the Y value looks to be between almost at 375. So I'm going to say approximately 370 people, because it's just below 375. Now I could figure it out by counting and getting a little more specific, but it's an estimate, so about 370 people. Estimate the the time intercepts of the function used to model this data. So the t-intercepts is fancy for the x-intercepts. So where does this graph intercept the t-axis or the x-axis? You just go and look at 0 hours, and then again we said here at about 12 hours. So by looking at this graph, we're seeing that the park is open 12 hours a day, and I really wouldn't want to be waiting online 5.5 hours into this park opening because that's when this roller coaster is the busiest. I want to hit the roller coaster in the beginning or closer to the end of the hours of work. Using the t-intercepts, write a formula for the function of the number of people in line p after t hours. Well, give me a second here. Let me clean up this page because it's getting a little busy. Okay, now the page is cleaned up a little bit. We're going to use the t-intercepts to write a formula for the function of the number of people in line p after t hours. So I'm going to use the function p of t. And now this is very important to realize because the population depends on the time. We found one of our roots to be 0, and that's represented by x. We found our other root right here to be about 12. So that's represented by x minus 12. We found this one to be 33, so that's represented by x minus 33. And whoops, there's a big error that I'm going to catch right away. It's not x. That's right, boys and girls. Hold those emails. No 5 points for you. It's t. Because the independent variable in this picture was a t, not an x. And that, yes, is very important. What is a reasonable domain for your function f? Now remember, we're just looking at this time that was graphed. So if we looked at function f, which is kind of a misprint on their part because they just wanted me to call it function p and now they're calling it function f. Oh, that silly Common Core module, yet another mistake, but who's counting? Anyway, it would be from 0 to 12 because we're saying that's when the park is open, from 0 to 12. So if we wanted to actually get an equation of this, well, all we have to do is use the regression feature on our calculator to find a cubic function to model this data, which we know how to do. We just need to type all these points in and do a cubic regression.